Hello. Hello. Hi.
Hello.
Hi, everyone.
Hi.
Thanks for joining so early. Hi, everyone. Sunga and Hanjun, please check your students. If they are more or less here, we can start.
All right.
Yeah. And unit 2 has 3 teams, and unit 2 has 2 teams, right?
Unit 3 has
no. Yeah, Unit 2 has 3 teams and Unit 3 has 2 teams.
Yeah.
So we can start with the Unit 2.
Okay.
Yeah.
Cool. And everybody, please keep your presentation within maximum 10 minutes.
1, 2, 3 persons here. A few days here. Yuki's here. Young Sun.
Hello.
Hi.
Hello. I think we are missing one student at the moment.
Cool. That's
I think
not
we are
bad.
missing one student as well.
Cool. Then we are aiming to finish within 3 hours maximum, with a bit of at the end a bit of discussion. But let's see. So Hanjun, are you there? Maybe if we can have our tutors from Unit 2 and Unit 3 just briefly introduce the unit, what the unit was doing for the other tutors and students who haven't seen the work for the last week. And then maybe we can start from Unit 2.
Sure.
Yeah, probably Namju or Janghyun, would you give a short introduction to about our unit?
Yeah, sure. I will introduce our unit. The unit 2 studied about the pedestrian flows and accessibility issues related with the COVID-19 topic. And what they are doing is that by using NNA toolbox, which is calculated pedestrian flows and densities and also pedestrian route choice issues. So based on this analysis, students analysis not only the urban context, but also their selected targeted design site as well. So they are kind of study both like human scale and urban scale at the same time by using network accessibility analysis. So yeah, that's it. If you have any questions about the method behind how to calculate the accessibility and network analysis issues, yeah, just bring up questions, and students also can answer about that because they studied a lot, and also the tutors can answer all your questions and queries during the presentations or after. Yeah, thank you.
Thank you.
Thank you.
Thank you. And should I go for it?
Yeah.
All right. Actually, I made a like very short intro, so I'm going to share my screen. Yeah. I mean, it's very. Just give me a second, please. Okay. Can you see my screen?
Yes.
Can you
Yes.
see my screen? All right. Yeah. So we are unit 3. So our agenda was social tuned network, agent and attractor. And yes, the Uje was our lecturer, and Hanjun, me, myself, and Jun was the unit instructors. So our main focus was about the agent system. So now you are seeing the enumeration of the birds. So we actually didn't manage this floating movement. But yeah, it describes well how the agent system can be looked like. And not only this flock, the agent system have various types of behaviors from these simple grids of the complex map like this. And the agent could only follow the given path and navigate, or it could be some, crowd simulation, something like this. So in the first of week, unit 3, we tried to execute the flow of the pedestrians into the script. So obviously, there are certain features in people's movement that we could take. Yeah, some are heading towards the certain target. Some of them are just strolling and wandering, or they just also stay near the place they feel attractive. So in this way, yeah, we thought about the linking agent system with the people and social figures. And this was our schedule, which was divided into 2 phases. And at the first phase, participants tried to understand the agent system by using Grasshopper and C# script. So like I said, we refer to people as agents and social figures as attractors. And since the behavior of agents are mainly affected by attractors. And yeah, since most of the students were new to C# script or any other coding, so our main lecturer, Uje, explained very well the system from the scratch. So we also started basic of C#. I think this was the only happy moment, I guess. And yeah, after that, we directly jumped into the complicated script. And yeah, and then so this was the what we gave to them, the research agent system. And right after the first phase, all participants directly started to research their own agent system by questioning what could be the referred agents and attractors. So meantime, they also investigated visualization of the script result. So yeah, here are. We have 2 teams in our unit, Team Yeonse로 and Team Hopper System. And Team Yeonse로 chose Sinchon, one of the most popular areas in Seoul. And while Team Hopper System chose the marketplace LJ in India. They simulated their own system on the site with some hypotheses. And you will see how they researched them during the entire 2 weeks. Yep, thank you for listening.
Thank you very much for the very clear introduction and the slides. Really easy to understand. Thank you. So shall we start from Unit 2, first group?
Yeah. So in Unit 2, we're going to start from Team A. Are you guys ready? They have executed several exercises through NNA tools and been to on-site surveys and analysis, and then they tried to impose the result of analysis into street-scale intervention. you ready to present? 지훈, 은솔, 하진.
어느 연락처 말씀이신가요? 박지윤, 구지윤 또는 정.
He raised the hand. I can see. There's some problem, I guess.
은솔, 하진.
Come on, guys, wake up! Wake up!
Please
All
wait.
right. Or maybe we can start with another team. Unit.
It seems like there's some technical issue, I guess.
I think maybe team B or C can start first.
Okay, then Team C, are you guys ready to go by chance? Thailand and Nada?
Yeah.
Okay, thank you.
Oh yeah. This is project in programming mobility. And actually, we were investigating the unexpected outbreak of the COVID-19 and how it changed the view of all architects and urban planners thinking about the model for a good city and how the good city, or how the pandemic resistant city actually should be, and what modification we can add to the city in order to respond to the current situation of the pandemic and ensure the safety of all the citizens. So, and we actually started to think about to study the network of the given area in Seoul in Korea, and in order to understand more about the network, the students we actually went on a site surveying and using different methodologies about counting the manual counting through the pedestrians flow to different destinations, and how this flows actually matches the prediction model that is actually used, and to understand the pattern of people in the study area. And upon the observations from the site surveying, we found that the market area or retail areas was actually the most crowded part of the city, and it's not the safest part. So we started to take this retail areas as our start point to study. To study the flow of the people and the flow of pedestrians to the area, and how this actually can be adjusted, and how this would happen would affect the network flow. If we impose some changes in order to ensure social distancing and ensure all the safety regulations. So upon thinking about the area, we started to think about the factors that could actually change the flow of the people in the area, starting from the distance and how far are people willing to talk, and the density of the area, because it's a very dense area, and the road hierarchies, and the sidewalks, its condition and width, and how can it change the flow of the people and the network in the area, the gravity of the people, and the presence of so much opportunities in the area, especially it is found in the center of the study area. And if there is any green areas, and how could that would actually affect the flow of the people. So we wanted to access which point was actually has the highest flow of the people and has the highest factor to change the flow of the network in the area. So we did multiple analysis on the area to understand which node would actually represent the main entrance to the market, and thus we can carry on using different simulations and different adjustment in this node to understand the flow of the people, and it started to make it as a start point for us to make our hypothesis and ensure all the safety regulations and the effect of our hypothesis and scenarios on this area. So we carried on a hypothesis from people coming from different origins, from homes and retail, from home to retail areas, and from parks to retail area, and from the metro stations to the retail area, and to understand the pattern of people to each flow, and how can these destinations actually affect the flow of the people. So we started to contain the between us analysis to understand the road hierarchies and that people would take to understand to access the area. And it's actually, you can see how the warm color represent the highest point which people would actually take to enter the area. And you can see from the home and from the retail, from the park analysis, it is almost the same point which had the highest hierarchical people. However, in the metro, people would actually take another entrance, which is in the red spot, to enter the area. And also for the gravity analysis, and which consider the accessibility of people while reaching the destinations, you can see that's how different destinations can actually affect the access of the area. But to some point, we actually also concluded that the main corners in here and here has the highest factor in attracting people to enter the retail market from this point. And that actually did happen also with the metro, even though it was different in the between us. And you can see through the reach analysis that access the different accessible destination areas within the area that still had the highest points except for the metro analysis. And we did that in order to access the different entrances of the area that we want to take to access, to begin our algorithmic approach to the study of the network, and how we can put these regulations, safety regulations, social distancing. So upon our analysis, we concluded that there is two potential points. The first potential point was actually here at the corner, which had been the main access for the pedestrians, which coming from the residential areas and people coming from parks, and which actually attracted a lot of people also coming from the metro, and had contained, as it had a high gravity index. And the second potential area was one from the main street, which would mostly people would take this route if they are coming from the metro analysis to the from the metro to this area. And it has a good betweenness and reachability for other people also coming from different destinations. But we chose our first potential point as it has the highest potential to affect the flow of the network to be an approach for our algorithmic approach, which Darian will explain. Darian?
Is she still here? Maybe she has a network problem.
Okay, I will start.
Yeah, maybe Diane can keep going.
Yes. Before explaining our site design suggestion, I would like to explain our two algorithmic work we have been working. First is our data simplification algorithm. We need to simplify our data because we have a home data. This home data is so really big. So we can simplify this. Our first strategy is to use grid system. A grid system, we put all the points inside the grid together. At the center of grid, we can simplify our data, but there are a lot of deviation. So our second approach is to use to our nearby node. We by collecting points on nearby node, we can able to simplify our data with small deviation. So we select this method. And our second algorithmic approach is social distancing and network generator. Let's see our short video like this. Scatter the human point on our target site, our main access point, and
Your video is not playing.
yeah, sorry.
Yeah, you have to share the whole screen.
Sorry about that. Yes, let's it's our social distancing and network generator. We scatter all the human points on our main access point, and then we can get a social distancing boundary and pedestrian network by using this. And then we can find also how many people can be there in our site. So the next is our overall design suggestion. There are some regulation. First, the vehicle access regulation and visual guide can give both of our market and street main access streets, and especially in marketplace, there are pre-designed pedestrian line and pedestrian number limitation on our marketplaces. By using our social distancing generator algorithm and smartphone, we can manage our market area. If you want to come into our market, you just check a QR admission. And there are many people, and you can also make a reservation by using your smartphone. And market area rule, people maintain 50 social distance by following just our social distance boundary circle and work on the pedestrian network. And we need to take a QR code when coming and going out. And this is left on the side. This picture is our original condition. And on the right, there is our suggestion illustration. There are orange circle is our social boundary, safe boundary, and white line is our social network pedestrian path. And the red circle is marketplace, for example, cafe and market, bank, like this. On the right side, there are access street. On the bottom side, this street is relatively unrelated street. So we can give a visual aid for access street on the right side. And finally, we can also analyze our internal algorithmic network. The first analysis is our degree analysis. This shows how many connection at one point. The red one is have a high value, so red one have many connection. The second analysis is our betweenness analysis. This analysis show which connection line can be easily overloaded. If you can see on the right picture, there is the board and red line have a high value. That line can be easily overloaded and the people come into our market. Thank you for listening our presentation. Thank you.
Thank you. And Nada, maybe do you have anything to add by chance? Because you are disappeared in the middle.
No, I was actually giving that chance to Darian to share his screen.
Okay.
Great, thank you. Well done. Tara, maybe can you share your screen again, and we can pause on the your best slide, and we can talk over that slide.
My screen or Darian's screen?
Any of yours, sorry.
Oh, I think because we have live in another country, we have make each other's part separately, so no one have a whole presentation. Nada, I think you share your screen first.
Yeah, sure.
I think it's a very in-depth work, and it's also very clear that you have a very specific scenario-based proposal at the end, and walked us through with a very rigorous set of analysis. So it was very clear.
Yeah, actually, in the case of Team C, actually Nada has been researched through all these hypotheses and developed the logic, and then Darian applied it into computational design through the scripting and everything. So they had quite a good match as a team, I think.
Yeah, in this team, they're even though they are living different city and they have like time differences, but they are really collaborate each other very well. And Nada really focus on the NNN2 analysis. So she studied about the general kind of site analysis at a urban scale for this whole site, Mangwon and Hapjeong station areas, and they end up find out the most interesting spot for their street scale design proposal. So I think they really focus on how the very unique this market area works well, and even after COVID-19, what they can do is that even though particularly this four-way street points, conjunction point is very crowded and very intensively pedestrian flows are happening there. So they try to find a solution how they can smartly make people can disperse in this specific location, but at the same time they also bring a very interesting programs. And so they want to keep the unique characteristics of the site as well. So I think they really find the smart way how to start with the urban network analysis to narrow down to the street scale and find a smart solution by using 6 feet, keep the 6 feet distance, and also bring the programs on the site as well. So it's very short time workshop, but they did very good work and very focused on find the very specific solutions and try to merge with from the urban scale to street scale, and even propose the kind of application as well. So I think it's very interesting approach and really develop further on not only just the network analysis, but also just like a computational design proposal. So they have a very strong evidence they proposed and they provided throughout this research. So as a tutor, I'm very happy with their work and their effort to produce these results. So yeah, I thank you a lot to Dalian and Nada.
I can tell. I mean, how such an amount of work. I mean, I can tell. Like, yes, like it was really intensive 2 weeks. I can guess. So great result and great research. Thanks for sharing that.
And thank you especially to Nada, because when we have tutorial, it was always like 2 a.m. in the morning at her local time. So thank you for your effort and everything and your participation.
Thank you guys. It was really interesting and really worth it workshop to participate in.
Actually, can I ask a question?
Yeah, sure.
So if you go to the second part of the presentation, if you right, so if you go to the very left page of the presentation,
Last page.
Oh yes.
Can you go to the
can
last
you
page?
scroll down all the way to the left? Yes. So
Yes.
I mean, could you please explain what exactly are you proposing here in this diagram? I think it's just a analysis between the different nodes and you know their traffic in the network. So are you proposing that, for example, on the diagram on the right hand side, so red is very congested, very dense traffic network, if I understand this diagram correctly. And then if you move up on the top right hand side, this is relatively you know free area. Right?
Yes. Yes.
So is it sort of like a visualization of the current situation based upon you know social distance between the node, or are you implicating some sort of physical things like you know the pedestrian path, the pavement, or something like that? Just out of curiosity. So yeah, in short, my question is, what is your final product out of this research? I mean, I'm not trying to be difficult here. I was just curious.
So what we were trying to do in this, we were actually trying to access which point in the main market that we should start on as an initial part that would affect the network of the people in this area. And we were trying to impose a solution for social distancing that people would use inside the area, so it can provide them with a safe journey in such a point or such a node which actually has a high flow in the network and high pedestrian flow and density area.
Right. So basically, you basically feed this information to your smartphone apps, right? And then you kind of use the app and then the map on the you know on your phone to navigate yourself to a safer area in this zone, right?
Yeah. So the number of the
got it.
circles, which yeah.
If I understand correctly, I think there should be two parts.
I mean, three parts basically. The first part is NADA was focusing on to understand the sort of entire site condition by using the network analysis, so that we are able to see like what is the crowded place or which one is like the place where we can detour, to modulate the path on the site. And they pick the particular sort of entrance, which is a very, let's say, complex, not complex, but two things happening like exit and entrance things. And then I guess Dahyun tried to deploy a sort of spacing algorithm to make a 6 feet like circle-like spaces, so that people can see visual sort of a marker on the street, so that they can like just like grasshopper, just jumping to different types of jumping to adjacent the circle stuff. I think that this is the idea behind the scene. And then the diagram you can see on the screen right now is more about like the mathematical sort of equation related to network analysis. The between analysis is sort of very well known and well defined sort of analysis to figure out the basically human footprint based on the people's flows. So the reason we can see very strong the red color on the right picture is because that there is, as I said, the exit and the entrance was located. So that it makes sense, because people once they enter that particular place, because we have a very particular, like, let's say the guideline, origin point and then destination, so that we are able to see which people use which network based on their position, starting point. So I think this is, it has nothing to do with the pedestrian, like let's say real flow. It's more about like accumulate footprint, so that we are able to which one is the crowded or not, so that Darian tried to, let's say, try to modify the network connect in order to decrease the flow of the people on the exit and entrance area, I guess. And with Jonghyun,
Yes.
Jonghyun, could you elaborate the bit a little bit in that context?
Yeah, I mean, it is very clear. But I think if you can use the VR in your smartphone, and then if you somehow integrate this type of data into your VR environment on your smartphone, then you can use it sort of like a guide to safe path through this area or something. I think this is a really interesting idea. Thanks for the explanation.
Yeah, and also on top of that, this betweenness analysis is also controlled by the weight, which is the weight also control the flow density as well. So I think this is just focused on the where is origin and where is destinations. And probably Dahyun just give all the same weights on all the points, but once it generated and we imagine the realistic situation, maybe center of this site will have a large circle, so it will have a larger weight. So the this color range will be changed. Like maybe if the network near to the large circle, which people can visit more, like within this area, like if there is a retail or shops, so people will accumulate more than other locations. So I think there is a kind of potential. What could be the next step is that Dahyun, you also design about or thinking about the different weight given in this site, and then you can also do another betweenness analysis and then make a more realistic kind of network condition after this. So yeah, and also as Ujjae tutor saying that this could be a really good potential to use for your application kind of in VR, like people can receive lots of good information, you know, people can take their safest kind of route choices, you know, that was our very initial kind of our like whole team, you know, like we study about the pedestrian route choice analysis and so on. So yeah, I think your research really showed a good potential. What could be the next, and even in the daily life, you know, if people have this information, people can take their safety route choice while they are traveling in the city. So yeah.
Yeah, I agree that there are lots of ways to take this on further. Of course, you did a great job until within the given amount of time. But if you could have also used this analysis to maybe suggest different programs for this each and every different single circular paths, for example, that could be another way of taking this analysis on further. One thing I think I mentioned before, but I am still doubt that like they will actually follow your path as it is. Like why wouldn't they go from here to there, for example? So I think you might also want could have been a bit more like instrumentalizing this network and really like use this as your very specific design tool and very actively just suggest what kind of physical installations uh, or physical like urban furnitures will occupy these spaces that are not the circulatory system. But I'm of course with the given time you manage to pull out the conceptual scenario. But what I'm just take this as a suggestion, maybe if you're interested in taking this further. Yeah, let's take one more comment and let's move on, and we can have further conversation when we come back to Unit 2 again.
Yeah. So for me, I can see the quite deep potential to develop this proposal for the future. So it is really good exercise and proposal, but I have just simple question for the first step. And I heard you guys got site survey to evaluate your analysis. So how much did you find? How much did you match those between your analysis of the network and real conditions? I'm just wondering.
I think that I explained that.
Yeah. So from the calculation that the guys had on the site, we did a linear correlations between the side the real calculated value that the guys observed and the prediction model that we used during grasshopper, and we evaluated an R value. For the optimum value, it would be actually between 0.6, and our value is actually 0.55. So it was a really close ratio to the real value.
Well, I think what Nada is saying that the value was compared to the digital value and used the real value as a test to compare with the calculation to see whether the discrepancy is too big or it's close enough. But I think I know the other units will show a bit more about how they actually surveyed. So we need to move on. So thank you very much. Yeah.
Thank you. Good work.
Yeah, very well done. Thank you very much.
Thank you.
Yeah.
Thank you.
So yeah, I think are we moving on to the maybe unit 3, I guess?
Yes.
Okay, so yeah, I mean, like same as the rehearsal, because of there's some issue with the video, so I'm going to share my screen and they will present. Can you see my screen?
White.
Yeah, white
White.
is fine. Yeah, white is
All
fine.
right, okay.
All right, are you ready, Team A?
Yes, I'm
Yeah.
ready.
Mm.
Here is our teaser video. Next. Hello, I'm Hyo-sun Kim. I'm speaking for our team. Our team members are In-tak Oh, Seung-hyun Oh, and Ju-yeon Lee. We are from Unit 3, and I will start my presentation. Next. Our site is Sinchon. Sinchon is one of the most busy and lively neighborhood in Seoul, having 4 university campuses nearby. The area is always full of young people. Next. There are 2 axes of streets crossing the area. The main street stretches from Yonsei University to Sinchon Station is called Yonsei-ro. The street gets full of various kinds of street events. Next. On the 2-lane road, only public buses are allowed to enter. However, with the plan of the local government to revitalize the area, on the weekend, they block the entry of any cars. Therefore, buses make a detour and bus routes change on the weekend. This kind of changing route confuses local people. Here, we got a question. Is it possible to keep Yonsei-ro pedestrian-oriented, but without changing bus routes every week? Next. As a solution, we came up with the scenario in the near future. We suggest just within 5 to 10 years, all public buses will be changed to be autonomous driving. Autonomous public buses we are suggesting is first, compact, returning more public spaces to pedestrians. Second, they transmit real-time traffic information to each other. Also, it slows down when it senses a pedestrian on the way. We suppose that when only autonomous buses are running on Yonsei-ro, we can keep street events without interrupting the public bus system. Next. Based on the scenario, we redesigned Yonsei-ro and tested through computer simulations. Here are settings of our simulation. First, we counted 1 frame in the grasshopper timer as 1 second in a real life. With this first rule, values were decided relevant to the real life. Second, to test if having street events are interrupting bus system, we checked the duration of the bus to arrive from start to the end and calculate the average speed. Next. This is a glimpse of a simulation we ran. We first checked the relationship between street events and the bus system. Blue lines are traces made by pedestrian movements. Next. We varied input of events and compared the time it takes for the bus to arrive to the end. The variable event gravity can be translated to attractiveness of events. Next. Then we varied the number of events. Next. Then we varied the size of events. We made several iterations for the same input to get the average results. Next. Here is for size 4 and next. Size 6, next. Size 8, next. So up to 10, the rows are getting organized. And if you go to next please. 20, like the bigger size is not effective anymore. The next, please. So event range refers to the radius it affects people, that it represents the size of events. Here we got a result that when the size of the event is as big as 10, the bus is the fastest, and when it's 2, the bus is slowest.
We assume that the bigger the size of event, the more it will interrupt the bus. However, we had the unexpected result that big events help to organize pedestrian flow by drawing them to the center of event places. Still, when the size was bigger than as much as 20, as I mentioned, events blocked the road. Next. Then we varied the number of events. The 7 events in the street showed nice flow of pedestrians, so we picked number 7. Next. Next. The finding made us to think of dedicating big space to pedestrians to strongly encourage them to walk along rather than crossing bus lanes. Based on the appropriate number of street events and the size we found, we set one path in the middle as the event section. Then, taking advantage of autonomous driving, we merged 2 bus lanes to one along the event section to maximize the public space. And we placed bus stops at each end of the section. Buses coming from each side pauses at the bus stop, transmit the traffic information, and depart. Next. The next step is to control the pedestrian flow better to prevent pedestrians from interrupting bus lanes too much. We placed street trees and street furnitures. Then, we simulated again to find out if these physical obstacles can regulate the flow. Next. Placing street trees helped for pedestrians to be within the pedestrian roads. Through tests, we had the best results when trees were 10 meters apart from each other. And there is actually a typo. Instead of 100 meters, it is saying 10 meters. I'm sorry. And next. Furthermore, we placed street furniture, such as benches and also more trees, and we could control the flow better. Next. By adjusting the amount of street obstacles and locations of them, we got our final design. Next. This simulation shows the flow we achieved with our design. Next. And this is the perspective view of our design. It is the end of my presentation. Thank you for listening.
Thank you very much.
I think this is sorry. I think this is great. You guys made huge progress from the day before yesterday. So one question for me. So if you look at the slide right here on the screen, so maybe I missed that part, but you basically started with 2 lanes street, and then you at the end of the process you narrow it down to 1.
Yes.
But here on this diagram, the bus is running on the white area, which is supposed to be a pedestrian path. So could you explain that just a little bit more?
I'm sorry. So like what it was said before is just right, and just I'm sorry that the simulation just that bus is showing an error. It is out of track.
Oh, okay, I see. So the white area here should be gray.
Just bus is appearing on the wrong location. Plan is right.
Okay, sorry. got it. But then the question is, the narrower street is wide enough to accommodate 2 cars in parallel?
Oh, so they are not going in parallel. It works like a traffic light system. So they transmit.
Right.
Yes.
Okay.
They
So
transmit.
yeah, I mean, yeah, it I totally trust on you on this, but I think it might make much more sense if you have occasional wide space along this path. So rather than you saying that you have to wait until that bus right on your left hand side on the screen comes all the way to the right, and then the next bus is driving opposite direction, right? That's the system what you designed here. So if you have intermittent the wide area, then would it help for your buses to pass through? What do you think? Do you know what I mean?
Yeah.
So like like someone just draw on the screen. How can I draw it right? Right. Rather than you have a bottleneck here and there, right? So if you have some sort of intermediate spacings like here and there, that way you don't have to wait until this bus comes all the way here, right? It's just my thought. What do you think?
What we were thinking is that I know I wanted to justify by placing bus stops that it needs to wait for some seconds at the bus stop anyway. And we did our project to control the flow of pedestrians interrupting like that one lane to minimize that. So
maybe I want to jump in here. Basically, I really appreciate what you have done, but on top of that, I still think you are missing opportunities of using this self-driving system because by using this kind of system, all the agencies are equally weighted within this entire system. So you don't really need a separated road for bus. Everywhere should be able to occupy, and using this simulation, you can actually simulate that like whatever bus is passing by more frequently, that will become a road and it's visible to the self-driving cars, but it's invisible for humans, for example. So this actually gives you a lot of opportunities to really free up like most of the road spaces, unbuilt spaces that becomes like can occupy different programs. I think it's still a bit of shame that you are still using the traditional road system and not really fully taking advantage of this.
I have a question and suggestions. First of all, thank you for sharing the work. I can see that a lot of things happen behind the scene. I don't know whether I'm correctly understand your presentation or not, but usually in order to simulating this kind of things, we have a very particular system such as void system, which is pretty well known and stands designed for address and try to mimic the scrollable feature of bird, So it has a very particular sort of steps to calculate the individual's the sequence of movement. So my question, first of all, is that what kind of a logic behind the scene to mimic, basically represent how human, works, basically, particularly on that particular site, because the human has a little bit different pattern against other animal like fish or like bird, because obviously there's a lot of attraction and interaction happening on the street. So I think I would like to ask you what happened, for each iteration to make a decision, right? Like what kind of step you guys typically because most importantly, this is sort of like complex system, right? One behavior can affect the other behavior. So in this context, I think the most important thing is how we design the action sequences. And based on the probability, we can choose designate rules, right? I think this is the interesting things I wanted to ask you. And the second thing is that, can you go to the slide that you guys talk about some design things like urban tree and bench can make some, better flow. Yeah, because I wanted to understand what is the result. Why we need to understand that design possibly improve the pedestrian flow. What is your kind of cost function? How we measure this is best compared to the past? I think this is the also interesting question. And one last sort of a suggestion. I don't know whether you guys deploy the sort of algorithm or not, but I guess the individual, the agent, the black dot on this screen, they try to decide the direction. I don't know, maybe you guys use some target or some multiple destination and then pick them, I don't know, based on some reasons. But the question is it possible to track all the individual, the basically decision sequences of the agent? And also, do they talk the site basically, so that on the site-wise, site is very static sort of condition, but when the agency occupy the particular area, that we can basically try to make a system communicating between dynamic the agency with the static site. So I think that there should be a lot of interesting finding, because every time you generate the path, every time you tweak the rule, possibly we can see some trend. You know what I mean? So I think that this is something like, I don't know, maybe you guys already deployed that kind of strategy, but yeah, I would like to mention, yeah. That's it.
Thank you.
I would like
Can I
to.
ask something? No, you go first.
Yeah, but just a quick one. Well, I mean, a great job compared to the Wednesday as well. I think you guys have worked so hard, I could see. So thanks for that. I mean, up to where these kind of slides where you were talking about how many events were more appropriate to not to disturb the traffic, etc. I think it was great, but your kind of proposal was in a way rather conventional compared to all this data analysis and all your sort of approach, the methodology that you used. So I think what you guys need from now on is when you actually, I mean, think about the whole process of the designing, because it's not because you've researched and you've analyzed all the data, and then I think you have to think about what this could lead you where, rather than okay, so what's the proposal? And then all of a sudden you kind of draw a gray street and a white pedestrian and with a bit of a street furnitures. That's probably something that you could have done without all this front part. So you really need to break that kind of attitude to bring on sort of some, let's say, good way practical proposal. But I think in this kind of experimental workshop, I hope you can break that kind of attitude. Yeah. But well done. I think I really appreciate your work.
Okay. I think one more thing I'd like to say, like, it's a good start. I mean, it's a good start, but I think it looks very dry. I mean, for example, I'm quite not understand what is size of event. Is it simply size area, or what it means? I mean, you know what I mean?
There was a slide explanation that so it is decided by input range, and range is a radius that I translated that like as like territory. So like
yeah, for instance, like a BTS coming up, that might be, you know, the size of event maybe 1,000.
and there was one more
You know what I mean?
input called gravity, and that is the attractiveness.
Yeah, yeah. So that is a good start. But you know, after that, I mean, you must be thinking about some kind of, you know, colorish, yeah, right? So I think that's why I say this is a very, very good start. I mean, very dry and is kind of bottom part of your start. But after that, now you have thinking about how gonna add on the more value, how gonna actually deal with the real situations, something like that. So I mean, it's a good ground. But if I using your knowledge, maybe I start to, you know, set it up some kind of adding value on this experiment. I think that make it more funny and, you know, got some good result at the end. I think.
Well, I mean, if I may support them a bit, like yeah, because since actually, yeah, none of them were known has any knowledge about all the systems and then on the script and both of them, nothing. So yeah, I mean, like you said, it's really good ground, and then they can go further. But yeah, I'm kind of appreciate of their effort to understand the logic behind. And then, yeah, I'm definitely sure that after this step, they should take the some next step like what Desmond mentioned and what June mentioned. Yeah, this is a really, I mean, yeah, even though I say like this is really good ground, but it is ground. You know, so I really want you two guys like keep researching and investigating about this agenda, and then for sure that you can have like the way better result, or like I said, not just better, where you can find the best way to how to use this logic, I guess. Yeah.
I think it would be great combining Unit 2 and Unit 3. I mean, I found a really nice diagram. I mean, weight diagram, because the
Yeah.
Unit 2 shows some kind of, you know, like a differentiated condition on the side. I mean, that makes, you know, it's more,
Yeah.
you know, convincing over there. And then that knowledge may be affect into the actual, you know, the agent movement on there. I think that is much more fun. So I think
Yeah.
that's why I'm saying. I mean, you have to study very, very ground things. So this is a first step, I think. So this is a really valuable thing. But you know, maybe next time if you're using those knowledge, you starting think about how gonna add on the, you know, like actual weight, or I don't know how you know call it, but you know what I mean? Because in nature there are no homogeneous space, you know, homogeneous thing. I mean, you know. So
I definitely agree with you.
yeah, so I like it. I mean, I'm gonna use it maybe, yeah. But if I you, I mean, I go further than this. That's it.
Yeah. So yeah, I mean, if I can add, like, so I really, I really definitely, I mean, I definitely agree with Daesung. So, well, actually, I really want to say to all Unit 3 students, like after this session, please have a look the Unit 2's all the videos, because actually the one thing this is from our project is like a lot of data is just based on the hypothesis. I mean, they didn't do any, like, to be honest, like they didn't do any like look for the real data at all. So, well, maybe they can be the one of the whole of the research. Yeah. But yeah, like, after if they can like research the real data, like Unit 2 did, then yeah, indeed they will have like a better, I mean, more realistic result, I guess.
Great. Let's come back to this discussion again. And thank you very much.
Thank you.
Thank you very much.
Thank you.
So Team A, are you guys ready now?
Yeah, we are ready. Hello, we are Team A in Unit 2. I'm Jun Chung, and other member is Unzo Che and Hajin Koo. Our topic is how to keep social connections during social distancing. According to a research, 70.5% of Koreans got depression and anxiety because of this disease. This disease lasts much longer than our expectation. It is called corona flu. In this situation, there are some movement to promote social interaction as the alternative of this problem. Our research question is how to keep social connection and during social distancing through the architectural design and urban design to overcome Korea's corona flu. Our site is from the Hapjeong Station and Mawon Station, Mapogu Office Station, and Hangang Eagle Park. This is our unit site, and our team is specific. Our specific site is here. There are Mangnidakil is well known for Mangnidakil and is Mawon Market. To understand the characteristic of our site, we analyze the site as many as possible. The concept of this analysis is centrality. The concept of centrality explains the hierarchy of the nodes or edges, and centrality index is useful to understand within the network of the flow tendency in transportation geographies. It consists of betweenings and closings and strainings. We analyze as soon as possible, as many as possible. This graph shows the betweenings value. It is from the origin is the retail store is the dot or all of dots, and to the entertainment. There are many values, Mangnidakil and Mawon Market and Food Alley. It means that there are much pedestrian flows. The between value is to measure the centrality. Is the total number of the shortest path at the target location is divided by the total number of shortest path that exists between the two nodes of given radius. So we think it's very similar to real data, because here is the very famous main street from the Mawon Station to the Hangang Park, and here is the Mawon Market and Mangnidakil. There is a high value. It means there are so many floating population. To figure out demographics in this area, we also analyze the number of households and residents of the different age groups using the open government data. The interesting is that the number of 30 population in 30 is near the Hangang Park and near the Mawon Station and near the Mapogu Station. However, population in 50 is there are so many. They are very evenly distributed over the area. We conduct an on-site survey to identify the correlationship between the our real pedestrian flow and between its value. We calculated. The location is Hapjeong Station and Mawon Station Office, Mapogu Office Station, and there are 46 spots. We decided these spots based on the between its top 10% and bottom 10% value. We did it last Sunday at 2:30 p.m. to from 2:30 p.m. to the 5 p.m. We counted the pedestrian and vehicle for 15 minutes. This is the video. We count how we count the pedestrian and vehicle. In this survey, vehicle means the bicycle and bike and electronic scooter. We did it for 15 minutes at every 46 spots in last Sunday. Based on the data, we calculate the we validate the data based on the Spearman's rule, Spear's correlation and Spearman's rank correlation. Based on this data, there is a correlation between its value we calculated and the number of pedestrians for an hour we counted. The rule is over than 70%, and with the p-value is less than 0.1%. So this means this data is very reliable to use as the data for the statistical tool. So then we use the linear regression model to fit the line, and with this calculation we can predict the number of pedestrians without the on-site survey. This is the result of our prediction model. We calculate all of the number of pedestrians based on the betweenness value. This number means the number of pedestrians. This result shows the number of vehicles flow for an hour. It shows that, but it's very reliable data. But however, it is show that there is a quite big difference in real data. What we think, because here is the Manglida-gil and Mangwon market. We usually expect that there is a very many people in this area, but these blue dots show that there is low population, floating populations. Also, we compare the real data provided by the Seoul metropolitan government, but there is a quite difference based on the local characteristics such as Manglida-gil and Mangwon market. So to approximate this model, we use these images. There is no real data from this website. So we get this image and we got the RGB value. And there are 5 kind of index from blue, green, yellow, orange, red. We using this Christopher algorithm, we got this RGB value and then use as the index and weights for approximate the real data. There is a quite some difference, but even we use this, there is still difference with real data and our model. So we decide to analyze the outlier. Outlier means there is 2 kind of rank. We count real data and we rank the betweenness value. There is a big outlier means there is a big difference between the rank count and rank betweenness. Orange dots means that there are very high floating population than betweenness value, and this very low population than betweenness value. So it is interesting that based on the there are many outliers in from the Mangwon station and vehicle. There are so many vehicle outlier focus on the food value. It means their outlier shows some local characteristics. So our concept is to make the how to disperse the people from the overpopulation space. We know that there is some outliers. Here is outliers. That it means that there is a very low floating population than network hierarchy. So our purpose is to disperse this overpopulation area to the this low population area by using the design. And with that, we also keep the over distancing and social interaction, distancing and social interaction. To categorize the street, we analyze some streets, 10 kind of streets based on the intersection and road width and pedestrian passage, and a program at first floor of the building and the number of floors and between its value. And we classified them as by the road width and the number of streets. And then we proposed the redesign based on this catalog. And this is the 1A section, and there 1A section is there is a we can go 1A, so we can do the redesign the facade to install the bench, or we redesign the road for the social interaction and social distancing. This circle is a 2-meter diameter, so people can keep the social distancing in this area. Also, we can change the geography. Two people can get a rest. This is the specific case, and we redesigned the paving, as people can sit on the bench and the floor. Also, people can get a gathering, keeping social distancing. This is a simulation using our algorithm. This is before of the 15 value, and this is the after of the 15 value. There, it means that there is a low floating population, and there is some kind of floating population. So this design can attract some people from the overpopulation area. 3A is there is a corner. We design this area using this corner characteristic. So at the wall, we design we can redesign the facade to install the bench or chair, or we can redesign the sun structure, or we can make some space. This is a specific case. Here is the corner, and here we redesign the bench structure. People can keep the interaction at here, and also people can keep the social distancing. It's the simulation of our design. So at here we can induce the people from the overpopulation area. Last case is the four-way. This is the here is there's two-side of wall. We can use this. You can use this characteristic as the design. So we redesign the space to plant a tree, or to people get gathering, or we can design at here center to for the people to take a rest. It is a specific case for in Dongyo 3. So we redesigned the park at the road for people to take a rest. It is a simulation of our design. This is the last slide. It shows our concept. I hope it'll be useful to understand our concept. Thank you for listening.
So you're done?
Yes.
Right. So I think this is really interesting project. So the one question that I have, if you scroll back 1 or 2 slides. Right here, so I'm still just trying to understand, but the diagram at the center. So you basically put a green space at every corner of the intersection, right? I think this is just to give people a resting space or something like that, right? Was it the result of pedestrian behavior at the same time vehicle traffic?
Yeah.
That it was my it was the question. So the reason why I'm asking is that by just looking at this diagram here at the center. So when you put a artificial island at the every single corner of the intersection, that it will have a huge implication on vehicles traffic, right?
Yes.
Was it your intention, or you're just you kind of thought that it might be okay?
I think it doesn't matter because we choose those area based on our data. All the places are the outlier. It means there is a low traffic in this area that less than is reaching value.
Right. That was actually what I was asking. Okay, sorry about that. And I think this is really interesting. Like I said, but I think right at this moment it is a bit dry. So if you can add one more ingredient here, like the just over attractions in urban context. So people don't really go to somewhere just because the street is wider, and then there is the seeing space alongside of the street. But they move because they have a specific destination they want to visit, right?
Yes.
So if you add another layer here, like attractions nearby,
yes.
I think that would make this project more rich.
Yeah, I think it's very interesting kind of creative because when we talk about the pedestrian route choice and pedestrian accessibility and this kind of analysis, the built environments are really important factors, right? So when students study about the accessibility analysis, we focus on the urban density, diversity, and route characteristics, right? So I think in this team, what they're trying to do is they try to just think about the density perspective first, and then they will also, on top of that, if you think about the diversity, which is about the urban program, right? So as a creative, like it's not, if there is a kind of just increase the density, which could be the structure or like furniture. Of course, people, you can bring people, definitely, I'm sure, because if increase the density, people will go will visit more than before. But if you can also consider about what kind of program you can build in, or what kind of program you can bring into your design location to increase the pedestrian flows on specific site. And also on top of that, you guys began to think about the route characteristics as well, right? Because you redesigned the street layout and street kind of improve the street paving design. So this is also part of the route characteristics. So I think in the end, like for your future development, you also think about like diversity issue. I think your project will be more realistic and more kind of interesting than now. So, but in general, you did a really lots of work, and even like just for one day, yeah, you did a very clear kind of an explanation and develop your design scenarios. So I kind of really appreciate all your effort and time and energy and everything. So we also thinking about the post-production, and I can see that you did a like kind of between this analysis with the before case and after kind of interpretation cases, but I can see kind of some kind of, no, you need some kind of improvement, even though you just showing us like kind of after interpretation and between this analysis, but I think you can make more realistic kind of results for the between this analysis. So I can talk with you further to develop to do the like model between this model adjustments. So yeah, if you really want to build a more realistic kind of between these analysis results, we can talk after more about that. So,
And I have one suggestion. Can you go to the page where you visualize population of that area? Maybe one more. I think you visualizing the generation of population in that area, 20, 30, 40.
Yeah.
I think the earlier.
Yeah, I think it was almost at the beginning.
The ages, you showed us the ages.
Generations of population.
Yeah.
Okay. I mean, this is minor.
Maybe here? No, here, this one, I think.
Yeah, I think this is minor comment, but I think definitely you need to take care about it because it's harder to understand. But I can see like a red color is a high value compared to the green color, but I can have a sense the relationship between in that scope. So for example, 10s, 20s, the image on the left, because they have a relative sort of difference, right? But I think the most important thing is that to reveal some insight, we need to think about how we compare these value, absolute sort of measure system, so that we are able to not only see the difference in the 10th or 20th generation, but also we can see the difference, between the population 30s and 50s that you mentioned in your presentation. I think this is just one thing you guys need to be careful in terms of visualizing data to communicate with other people who has no idea about your projects. Okay, this is just one comment.
Yeah, so your team really focus on like kind of try to make a bridge between design and statistical analysis. You did a lot of effort on that. I know about this. So, but like, I can see a lot of potential on that, because you have a really good eyes and thoughts about the statistical approach while you are doing the urban design. So I can help you out. You can go further for that. So yeah, but in general, you have a really good start and a very kind of evidence-based, try to go for the evidence-based urban design research and analysis. So I really can see your effort.
one thing also I want to emphasize is that, everyone talks about data and, first industrial revolution things. But I think one thing I wanted to mention is that he actively used the statistical approach in terms of looking at the urban with data. So I think overlaying another layer which is well defined, dealing with the number. So I think the lens with the statistical approach is a really give us fundamental, profound foundation to see the urban context with data. So I think this is also very, good, strategy for designers.
Okay, can I have one mention?
Yes.
Yes, please.
Okay, I mean, the beauty of this project is still within data and statics, numbers, right? But the numbers on the statics must be meaningful, significant over there. Otherwise, we can drag all kind of numbers and data and then we can show it. But we can do that things. But you have to, why that is so meaningful, why that kind of value in become a ground for your intervention on your site, something like that. So that sense is quite interesting. You choose like a critical point or strategical point on your site, and then you suggest some kind of design over there, right? But that's it. I mean, you have to reevaluate that after you design, and then you prove as your data set again. That's the beauty of your things, right? But you just analyze and then you just suggest some idea and then that's it. So I want to see something different value from your intervention, not just you decision maker, not at all. I mean, that's not your strong point. You know what I mean? So for instance, okay, maybe I found that point, I designed something different way of road system, and then you evaluate again. So what happened? You have to compare with the different data set, and then now we understand that you design is how the effect on the actual side over there. You know what I mean? So
But he did a kind of before and after analysis a little bit, but he couldn't complete the kind of regression analysis yet, but at least the between this analysis before and after shows how those urban contexts, how impact on their own design. Of course, it's still under progress, I think, but at least with this diagram, we can get a sense like how those pedestrian flows and densities are kind of changed by their design interpretation. But as his critic, beyond that, we can also, I think but what I can see here is that you have to adjust the weight value on the site, and then you have to make more precise adjustment kind of model to do the betweenness analysis. So, and then after that, you can do the regression analysis, how those are different between the on-site survey and these computing results. So I think that could be the kind of your next step. And of course, this design didn't really complete yet, I think, right? This is still your kind of very scratch kind of idea to, you guys just try to do kind of some kind of intervention and very kind of abstract idea on that. So yeah, as a critic, if you can really more narrow down to see how before and after are different each other, and then even further on that, show how the regression results really show different kind of value with the on-site survey will be more valuable. And you can, it's kind of really good way to make decision, right? Like lots of, as I lectured like previously, we talk about how we can make make decision makings, you know, while we are doing design, right? Of course, aesthetically, the designers can make decisions, right? This is better than that and that. But by using this kind of evidence-based analysis, really help even not only for like urban planners and or like policymakers, you know, like designers also can kind of make a really better decisions for planners, right? So I think the beauty of this kind of approach or this design progress is about that, you know, we designers always, we just like use a given data or like given rules from the planners. But if you have this knowledge, even though you are designers, you can give kind of new planning rule or planning ideas to the planners or policymakers. So I think you have a really good kind of potential go further the more. So yeah, but it's a kind of good exercises, right? To do that.
Yeah, thank you, John. Yeah.
My understanding of Desmond's question is that like, so we rely on sort of network analysis system, right? Network analysis system is basically how we abstract the urban as a sort of node and edge, which represent a place and connectivity. So I think you did very good job to understand what the pedestrian flow and density in the urban context. And then we narrow down, pick a particular place, right? But I guess there's still some opportunity to narrative for what's happening, how we regulate which happening in one node, for example, or one edge between node. So in that context, we can focusing on like even the personal or people's person scale to how we design the street between two nodes, right? I think that this is also one validate point to, let's say, you made some design decision, you make some intervention on that particular street. And then, I mean, the network analysis gives us a point to analyze in your design intervention, but also we can think about like how we, your individual design elements, how affects the sort of flow of the people in that particular pathway between nodes. I think this is the one thing we can really think or really visit here. Yeah.
Thank you very much. Thank you, Anje and Changyun, for explaining, and also Daesung, thank you for the critical question. I think also this is a good chance for students to also get some feedback from other tutors as well. So please don't be too defensive. We all understand that this workflow is really valuable. And I'm sure students are really grateful for the experience. And but I think it's also good to see what other people from a bit of distance to see what is the perspective from their point. So I think that's also quite valuable discussion. Thank you. And shall we move on?
Yeah. So I was thinking that there's another team, but yeah. And then so yeah, we're going to do our team B. And Yang-san, are you going to share the screen? Yeah.
Yes.
All right. Yeah. Please go ahead. Control L is cool.
Yeah.
Yep. Shall we start?
Yes, please.
Hello, this is Yuki, Yang-sun, and Abhyuday, and we are Team B from Unit 3. And we will be looking at a very special type of vendors, the hawkers, and that is very popular in many different countries. Next. Our focus issues is the hawker system. So in India, like Panagar, the hawkers have always been an integral and indispensable part of the city. They are easily transported and can be found everywhere on the street and provide a wide range of items at a very low price. So while large Panagar has a high population density, the moving hawkers have a high competition in the street market. Therefore, they are moving around the city and try to find the locations with higher exposure to the customers. So our goal is to analyze the system and to find the suitable location for the food hawkers to make a sale. Next. So first, I would like to introduce what a hawker is. A hawker is a vendor of merchandise that can be easily transported. Hawkers often advertise by low street prices to attract attentions and enhance sales. There are also many similar types of moving vendors around in the world. For example, you can see on the left, this is Yakult in Korea and some of the other street food sellers in both China and the United States. Next. In order to analyze the hawker system carefully, our team first analyzed the sites, which is the central market of large Panagar. We have labeled it in the green area. Next. We have classified the local shop data with different types of shops, as you can see on the diagram. And for our experiment, we will be looking at the local fashion shops, which are the footwear, clothing, and textile and the jewelries shops and all the three types of shop as a group in general. Next. For our research, we will be focusing on the food hawkers. The food hawkers have a relatively higher mobility, and it is a popular type of vendor that appears over the world. And also the food hawkers will be naturally attracted to the local fashion shops because they have relatively lower selling competition to each other. Next, please. And to begin, I will first introduce our workflow. Our research has been divided into two stages. The first stage of our simulation is aimed to find out the most popular customer routes relative to the local fashion shops. By using the C# script, we will be able to find the customer cluster and therefore define the most popular customer path. I will explain this process later in detail. And next, please. The second stage of our simulation is to use the result that we gained from stage 1, the popular customer routes, as the path for the hawkers to move. And our goal is to simulate the behavior of the customers and finally find out the greatest density area of the customer cluster when the hawkers have been added into the system. Next, please. The social data that we have considered and experimented with the script is by adjusting the following 3 factors. They are the relative distance between the customers, the walking pace of the customers, and how much distraction will occur when the customers move. And next, please. So now I will explain the process more in depth and pass it to my teammates for presenting the results. First of all, the customers are moving randomly generated by the script, and they will move randomly towards the local fashion shops since they are naturally attracted to each other. In this diagram, the customers are following the green dashed lines towards the local fashion shop. Next, please. After the simulation, we will extract the data by combining the routes. By doing so, we will find the intersection of the routes. The results showed the location with the most customer exposure, which is circled in green. This path will later become the route for the hawkers to move for stage 2. And I will pass it to my teammates to explain the simulation that we have. Next, please.
Yeah, so Avira this side, we experimented with different, so part one of the simulation with variable distraction and all the factors affecting a person's movement inside a space. And it tries to just imitate the pedestrian movement, and you obtain the intersections between the various paths followed by people who are going to shop. And then next, please. Then here are some results from our analysis. So, like, we obviously cannot accurately model human movement and human intelligence, but we can trace their trajectories and come up with useful results. Next, please. So these are the patterns which are obtained. So after running multiple simulations, we analyze all the intersection points, and in the red are the intersection points which have the most exposure for the hawker. And then we extracted the red points, which are the highest density, and then we establish a territory in the magenta line on the right diagram, and we further graded the territory established to get even more precise results for exposure for hawker to sell. Next, please.
I will explain the second stage of our simulation. So in our second stage of simulation, we added in a new attractor, which is the food hawkers. This gray dotted line is the result that we obtained from stage 1. And for this stage, we will simulate the interactive result between the customers and the two attractors. Next, please. And this diagram shows the relationship between the customers, the food hawkers, and the local fashion shops. The customers will be attracted to both the hawkers and the shops. So as a result, our goal is to analyze the system and to find the suitable location for the food hawkers to make a sale. And I would like to pass it on to Abdullah to present the simulation.
So this is the final simulation which we have obtained. So as you can see on the floor, the pattern on the territory shows the most exposure points which are obtained from daily analysis of data of movement of people. So by doing this, we can help hawkers assemble themselves in the areas which have the most exposure to the customers. As in purple moving cylinders, you can see people, and there are white donut shapes in front of the shops, and in the red areas, not in front of the shops, but in the red areas, which denote the hawkers. Sorry, but the simulation is not smooth enough, but it shows the interaction of efficient interaction of people with hawkers. So what we have tried to achieve is to come up with this with an efficient territory with a gradation for exposure, so that hawkers can assemble themselves in the Lajpat Nagar market area for a better sale. Thank you. That's all.
Thank you.
Thank you.
Thank you.
I appreciate your works. I can see a lot of things happening. As I said, you guys learn like C#, which is pretty hard to learn, for the beginners. And I can see some particular result out of it. But you know what, you guys, I think, I don't know, this is just personal opinion. When you say like a random generated by script, which is like, it's no good for making your product stronger. So you need to articulate the steps and list, not using random algorithm, okay? Because randomness basically talks about the probability between 0 and 1. So maybe you can designate some like some rule based on the probability, and then you can articulate, oh, based on this one, if the conditions meet that one, and we're gonna do this action, otherwise do this action, just like that. And also, could you jump to the popular custom routes slide in the first stage? One more, the before, I think. Previous slide, I guess. Okay, here. Oh, yeah. So I think this is a similar question as I raised for the first team. I think I don't know what kind of logic behind the scene that you deploy to mimic the agent, but I can see like this trajectory of the individual particle is not like from human being, I guess. So and also I can see the the high density of the path there. You guys said like this is like a high spot or something, but I can see this is a very deterministic result because you guys installed the object there, right? That's why the agent starting from their own origin to that destination, it makes sense. And also they created some like very congruent like a place where around the surface of the building footprint. I think so in order to, I mean, if I were you, we can use the sort of agent, let's say, system, but at least we can generate some path because human like a working like behavior, it has a little pattern if you have it observed on our street. So you guys, I think best way to relieve this kind of random sort of paths on the screen, I suggest you to create some sort of possible paths, as many as possible. And then individual paths has their own probability, right? And then the agent can take that path for the certain, like certain time when they meet the condition or some rules, I guess, so that the agents at least they can embed on that site. So that the individual paths become more convincing to other people who has no idea about your works, right? So, and then also go back to next slide. Next slide. Yeah. So if I remember correctly, so you guys said this is sort of a result. Yeah, I think it's result because, as I said, the rule is quite important in that kind of agent-based something, because the rule is all about. Rule is basically sarcastically create the result. So I think as long as you keep the right sort of rule in that perfect world that you guys set up in terms of the rule, basically, and then the result can be interpreted different way because this, the result is a sort of deterministic result from the sarcastic sort of environment or parameters. So I think the result in my eyes is very similar to the first the trial that you guys generate the random paths. So I think, but still there's a lot of opportunity, and throughout this sort of practice, we are able to learn how individual agency interact with other agency and then leave some sort of footprint on the urban context, in just like this slide, so that we are able to get the sense of what is happening throughout the history of the agency's interactions. So I think this is also a good perspective. But I think I'm just wondering what kind of rule is dominant sort of guideline to the movement of agency. So I think this is my general question. Yeah. But other than that, I think the story, the team A, team B is very solid, and then the scenario and hypothesis is absolutely validated, and then we can find some like, you know, some interesting results that we couldn't imagine without this kind of simulations. Yeah, I think this is a very interesting point.
I have also a question about on this slide. So you have 3 diagrams and with different index colors. So can you explain how those are different each other?
So the first diagram, the top left diagram, shows all the intersection between the trails of people or the paths which people have followed. Then out of those intersections, after multiple simulations, we tried to take out all the areas which had maximum intersections, which is the bottom left diagram. And then after using the bottom left diagram, we established a territory to further grade it in order to give specific routes for more concise areas for Hooker to decide or to judge where he can have a better say.
Yeah, what I ask here is that actually, yeah, if you use kind of like random situations, anyway, this value just showing about the accumulation data, right? Is it correct?
Mm-hmm.
So I think this is kind of really interesting and very kind of, I can see kind of like potential because anyway, okay, this is a random situation, so you don't know which path people will use, or but at least this showing about kind of accumulation data. So more red color represent more pedestrian flows or like footfalls on this area. So if it is random and you still cannot really set up your own kind of logic behind, maybe what I can suggest is that you just count or like get the data from each shops. This is the actual site, right? It's not a virtual site. If you can get a kind of like the customer's data for each shop, for example, and then you can also compare with your this analysis, you know. So of course I can see some shop has like maybe lower index value than the others. So that could be a kind of to understand your this the analysis better, because and then you can confirm about your analysis scenarios as well. So that could be kind of good approach while you are developing or setting up your logic behind this analysis. If you don't know what exact kind of, I don't know, the gravity or speed or like, I don't know what kind of system you set up behind this, but if you really want to more specifically develop your rules for this analysis, maybe you can also get the actual data from somewhere, and then you can keep kind of narrow down your scenarios or logic behind.
Now, also one thing I just can see is that basically we can abstract this kind of simulation, right? So we have an agency, right? So agency is basically like a dynamic entity, right? That follows some attraction, which is the other system, like the static environment. We can call it like some place where people can gather. So I think we can sort of, I don't know, I mean, if I understand correctly, the agencies basically learn on top of this sort of environment, like attraction, speed, or whatever, the designated parameter, right? But what I'm saying is, what if we create some reciprocal relationship, like the individual agency move their own iteration, and then they communicate with this some sort of the environment that they play. So for example, like one food truck, for example, and then people try to gather it, right? That one is actually increase the the attraction more, right? So then more people can aggregate in that place, right? I can see this kind of pattern a lot if you go to like other shopping mall or some street like yeah. So I think think about some rule and different probability based on the in terms of basic define the relationship between the agency and the let's say the environment reciprocally, and then we can actually finding some interesting. I mean, the finding the relationship is also become like a research topic, I guess. Yeah. So in this context, rather than just play with the fixed situation, we can basically try to find what is the better situation, better relationship in terms of the different parameters, right? So they try to reach like a converge their own sort of like an aim. You can actually install any other sort of cost function for the agency-wise and the attraction-wise, so that we can play as much as we can, and then we can see which parameter can give us like a optimal parameter, optimal result out of this multiple scenario. So I think there should be some relationship, or particularly the parameters between agency and the playground, the agency play.
Thank you very much. I think they are very good sets of very practical suggestions how you can develop your project with more precise rule sets and environmental understanding. So you can take that as extrapolate that kind of suggestions. Of course, you understand that the design methodology we're taking is not really based on a very precise understanding of building up the agent's behavior, isn't it? You are using a very kind of maybe very simplified version of crowd simulation that is not really simulating human particularly, but it's more general in terms of its behavior. But I think the set of suggestions you can take on is that what I think it's valuable in this model is that you build up a model that is actually it's object oriented, and you can actually structure the behavioral or behavior relationships, so you can add more precision on top of that. So you are in the very beginning of this model setup, but that's very valuable. And then you can take on more and more like more precise suggestions on how you can develop this further. All right? Yeah.
I think, yeah.
Okay, Tae-sung first and Jae-won.
No, I mean, just have an idea. I mean, we have a session 1, and then we talk about deep learning or AI thing, right? And then we put the lots of, like a data set from, like a tube station or train station, and then finally computer realize some kind of pattern over there, and then, so, I mean, in this case, we try to build up on logic, people's movement or something like that. But, that is a really, I think it's a really huge burden to analyze all, humans' behavior kind of thing. So rather than we using like an AI thing, is maybe, like easier than this approach, I think. You know what I mean? I'm not sure, but
yeah, that's
I thought like, yeah.
Yeah.
So if I don't know how to do that, but if I, to extract some essence from AI, and then we might apply into the agent system, will be more interesting.
Yeah.
So
yeah,
check the like a unit 1 and unit 4 will be really helpful for your future study as well. So it's not just that thing.
And Jay?
Yes, I think I quite agree with that songs. It's quite nice idea to do that actually. And also, what I liked from this project, I think they anyway draw and demonstrate the complexity of the city by computer, not by hands like us.
So I think in a way it's quite interesting to look at. And I think the unit 3's kind of setting some kind of lecture from the Uje was kind of big moment to do those kind of stuff. So I think this is kind of one of the big kind of dimension opening. So I think I'm gonna see more about next time to do more. I think maybe we're gonna have a discussion how to do maybe later this conversation. Thank you.
Thank you very much. We need to move
Thank you
on.
very
It's
much.
our last project. Yeah. Thank you very much.
Thank you.
Thank you.
Thank you.
Last project from Unit 2.
Will be Team B. And Team B actually tried to analyze the network around the neighborhood, then disperse the density flow into some open public space within the neighborhood by designing pedestrian paths inside some selected sites. Ready to present?
You guys can turn off the KakaoTalk machine.
Okay, can you hear me?
Yeah.
Okay. Hello everyone, my name is Jongdae Kim, and I'm gonna introduce our network design project called COVID Arcade Pramina. The goal of the project is to provide safe area for social activity by utilizing dead space through the COVID-19 era. So, in this project, we suggest a new type of third place. As you know, the original third place was on the commuting path, just like this. Especially in Korea, the public transportation is very developed. So this kind of place is easily crowded by the commuter. Since there is a potential risk of infection, this kind of place needs to be avoided. And recently, the portion of the telecommuter is increasing. Therefore, the third place should be near to our house and should be spread it all around. So our final objective is to attract people to select this nearby area, not a far and popular one like this. Then we can minimize the risk of infection while providing the services people need. So our project suggests using pocket park shaped like this, or the schoolyard as a third place. Recently, these kind of places are not properly operated due to the infection control. If we reactivate this area, we can easily provide a new third place to citizens. I think that using school and the pocket park is a very appropriate way because school is one of the most important elements for city zoning, and also the pocket parks are evenly placed in the urban area. So we can say that this kind of approach can create the model design, which can be generously applied to any other city or country. So the challenging point of our project is selecting the proper target area. Sorry about that. Yeah, but fortunately, we can solve this problem by using various functions of NNA tools. Thanks to the tools, we were able to visualize many features in network. One of those functions I'm going to show is the betweenness analysis. Simply speaking, betweenness value means how many people visited certain point on the network. In these figures, red means the busy road, and blue means is the quiet. So if we gather all the values on the network, we can actually read the flow pattern of the pedestrians in this town. These three diagrams show the flow of the pedestrian from three types of origin to the Hangang River Park area. This data is from home, and this for retail, and this for entertainment. If we overlap these three data, we can see the general feature of the network. Here, especially here, we can see that the entrance of the park is very busy. Through this, we can easily set the position of our project site, which is away from this road, because of our objective is to spread these overcrowding people to quiet areas. So in this time, we set the destination for 8 candidate sites for our project area, which is marked with a green hatching. And then we did the same analysis, just like the previous page. And so we can see more evenly distributed pattern than before, which means our location is proper to our objective. And then we evaluated our target area in terms of residential allocation. For this, we used the reach and gravity analysis. First, the reach analysis shows the allocated area for each target based on the pedestrian's walking ability. If we assume that people can walk from 0 to 150 meters, only these range of pedestrians gonna make it to visit our target. So, but if we input the general walking value, which is 0 to 500 meters, range will be expanded like this, so that much region can be covered by our target. And also there is another factor called beta value, which is used to gravity analysis. This reflects the unique characteristic of environment. For example, what country is, what city is, or how is the weather like. If the beta value is low like this, it means the walking environment is very harsh. But in our case, we set the general beta value for Seoul, which is 0.004. And by this, we could meet the fine result like this. And those were whole process of using NNA tools. And then we also made on-site survey to prove whether the analysis tool fits to real life. We counted the actual pedestrian number at 45 different locations in Mangwon-dong, Seoul, and compared it with our calculated data. The correlation between on-site and NNA tool was close to 70%, which means NNA tool is quite accurate for this area. And the area which showed the outlier data was excluded our project candidate and remained this fourth area for our further design. And so by adding our fourth target area as the additional destination, we could see effects of our project. Increased portion of green dots on the map shows that we successfully balanced our network. Now we're gonna design inside network of our target area. First, we check the adjacent road of each area. In this chart, each column shows the betweenness value weighted by population data of certain age. For example, this is for teenage and 20s and 30s and so on. And the last column is for total ages. Based on the last column, we can set the direction of network and the position of entrance and exit. If we properly select them, the unbalance of surrounding will be eased. right? By the way, we can see the highlighted value that show the difference between several ages. I think it will be also interesting to reflect this age-specific demand, but we could not cover it in our project this time. So back to our project, we created catalog for target areas. We classified our target area into 3 types: the triangle, the square, and rectangular. And then we specify the cases based on the number of adjacent roads, which can be used as entrance or exit or both. And then we even subdivided the cases by area dimension of 10 to 3,000 to 3,000 square meters. Through this, we could make the various type of conceptual design on network. And then we made detailed examples for concept design. These are the triangle area, and these are for rectangular area. And after that, we actually injected our simplified design into the local network. There was a slight change in the betweenness value, but not so dramatic. So we concluded that we should make more specific and complex networks. So we developed a catalog more specifically. First, we set the rule of network line. By the 6-feet rule, we set the width of main line to 2 meters in case of one-way traffic. For the two-way traffic, we double the width of one-way. And there is a subline. Subline means it is diverging from main line, and the first line means it goes back to the diverged line. And the second means it is case of dead end. So in this case, only two-way traffic is logically proper because we have to go back through the way we came from. And also, we create the real size object, including various services such as the gallery, the cafe, food truck, or library. And after that, we made combination of objects which called module. We created 3 types of shape similar to our target area, and we also made some variation of components like this. And now we applied our catalogs to our 4 target areas. This is the layout of the components for Chandari Children's Park. The shape of the area is triangle, and the main concept of the main road is zigzag line. And this is betweenness analysis changed by network insertion. And this is for Mangwon Elementary School. We also use zigzag concept to rectangular area this time. And this is the network analysis. This is for Dongyo Elementary School. Sorry, I have a problem with my camera. But anyway, I will go on. This is for Dongyo Elementary School. In this case, we use a complicated loop for network concept and its analysis. And this is for Mangwon Grand Park. The area dimension here is much bigger than other areas, and we applied various patterns. And after all design, we inserted our core network geometry to entire city map. After that, we analyzed betweenness value. We can see that the adjacent roads around the target area are balanced well through the proper design of inner network. entrance and exit. And finally, this is ISO and elevation design image of Mawon Elementary School. This shows the scenery. This shows the scenery that pedestrians can experience through our main line of this area. And also, we can show that our inner network design fits to the 6-feet rule with red circles under each pedestrian. This is the last of our presentation. Thank you for listening.
Thank you very much.
Thank you.
Thank you.
Okay, maybe I can start. As I said last time, I really like your approach by trying to utilize the network analysis and developed it as your design tool and occupying a empty space and giving a proposal. And I think you managed to make a very convincing diagrams. This page looks really great. As I understand, you are designing a school public space, is it? Yeah, is there or maybe I didn't get that point of this. Can you actually go back to your diagram? Okay. Anyways, I think the other day what I didn't really get it is that I thought you are actually also designing where the built elements will be, so the actual school will be also integrated within this area. But now it seems like it's more like a outdoor park kind of landscape design. Is that true? And like all this gray area is just empty. Is it correct? Well, when I was looking at your diagrammatic plan last time, because it was not as actual as this proposal, you didn't have the 3D model by then. So I thought you are also defining where should be the built volumes, and that is the school volumes. That's what I understood, but probably I misunderstood that. What I really like about this is that you are creating your network, but yeah, this is a bit distracting. Can you go back to your page?
I think he has some kind of technical issue.
Yeah, sorry.
Can I share it?
Yeah, sure. Okay, so, but what I'm saying is, I have similar issue with the first team. When you are generating network, I think, or the circulatory area, the other area that is not circulatory is something built, or even if it's a garden, it's a built area. So I think I think I'm a little bit confused because you are designing your road and you are taking that road as a built area, and then you are designing, you are extruding the road literally and building like bridge or like things around it. But I think I'm really curious, how do you deal with the void area that is not circulatory area? Because I think naturally in the city, non-built area naturally becomes a circulatory area. You know, so I think that relationship is really important. And it's totally fine that you start by generating the network and then occupying the rest of the spaces. But I think you might want to be more intuitively think about the relationship between what's built and what's circulation. And yeah, by doing that, you might want to develop certain kind of more generally understandable relationship, like in terms of the built physical environment. For example, if you cut a section of a road, maybe you had that a lot of sections in Unit 2, which was second team, which was really good. And that really defines on the relationship between the facade and the street, and the garden and the street, and so on and so forth. But I feel like you are taking certain methodology, which is really interesting, and then you are just building that area without really considering the rest of the area that is not occupied by your circulatory system. And I want to know what is your view on that.
Oh. Actually, I'm not sure that I totally understand the feedback. As I know, you are saying about the relationship between void space and the building environment, right?
Yeah.
At first we focused on the void space in our city because we can feel some programs or other installation for some event I have run. The void is the possibility of the is the space of the possibility in the city. So that is the strength of the city. So at first we want to make some temporary installation, so we can put the item on the void space, and then uh, uh, so in conclusion, we want to design the temporary module, but we finally made not temporary. So we think the void is important in the city, but that is our limitation of this project.
Yeah, maybe I just add on explanation. Yeah, actually, the Sumi's comment will be very helpful for his next step, because in this project, students began to think about the network first, and then how they can fill with the void spaces next. Because while we are just in generally, when we design the city or architecture buildings, we always think about how we can make occupy the space first, right? Which is where could be the room, and where could be the, like, I don't know, like maybe the shop, or even in a like urban structure, like where we located the retails and where we located the offices. That kind of idea we just set up first, and then maybe we think about the circulations and the network issue maybe the next. Of course, we are always doing the kind of like the consider both at the same time. But if we say about which the older things, like maybe we always think about the space first, how we can make occupy the empty space. But in this project, like students just first think about the network first, you know, before just fill with the empty space with the programs or densities. Students just first think about the network or circulation within a space, and then the next step, students think about how they can what kind of shapes could be in a like void, let's say void spaces. So because this is network analysis kind of studies program, so the design approach could be the different way than kind of like let's say normal like traditional way of design progress. So because we use empty space as just the weight value, you know, we doesn't really consider or like think about the shape of the buildings or shape of the structure yet. But students more focus on how they build the new network in an empty plot, which could be very useful during the weekend, you know, like afternoon peak hours. So they just began to think about the temporary installations and how they can build how they can useful network for these temporary installations in an empty plot. So yeah, I think the Zoom-in's comment will be very helpful for next step. Like students also think about what kind of shape could it be in an empty plot and how people can also use the network, you know, the empty plot as well. Like students here kind of showing more kind of main circulatory issues in this type, but the next step could be that students can also design or think about what kind of more kind of narrow down kind of network condition for empty plots as well in a site.
I have a one wondering. I mean, you know, once you study occupied space, but space means three-dimensional stuff, not just 2D. But I mean, I don't know, networking is kind of relation is quite, you know, like a great strong ground to decide certain, you know, decision for the where is located the room or something like that. But I'm feels like that knowledge is directly into the, I mean, translate into the final design. I feels like that. I don't know, because I thought like these guys tried to make really nice urban void, or maybe they put on some, you know, like you know, very critical urban, I don't know, the bench or kind of, you know, I call like urban toy or something like that. So it's make in niche the area using that things, but I feel that feels like a, you know, like I don't know, because 2 weeks work, and then he's a bit ambitious, and then he's I think he's brave guy, so he tried to push his idea into the design. That's why it happened. So I mean, so it's a really good start. But if you deal with the void, I think maybe think about the three-dimensional approach as well. I mean, not just extrude or divide the length. You know what I mean? So I mean, triangular shape, as I showed us first page, second page diagram, is that is quite interesting, because those already have kind of, you know, like a three-dimensional approach already there. So a bit interesting. But suddenly final one is a really bit like, you know, yeah, that one is, I mean, these guys think about how to deal with the actual, you know, space. But final one is really bit like suddenly, you know, I don't know, but so two-dimensional one. So yeah, that one. So you just divide the land and locate, you know, some stuff over there. So I don't know. So I'm really expect like a more dynamic things. You know what I mean?
Yeah, I guess to answer your question, first of all, I think it depends on how people interpolate the result out of network first. And then they can make their own decision, like a design strategy to maximize or minimize the result. And I guess in this team, they analyze just like other teams, and then they find some particular spot that they wanted to take advantage of it. So basically, they, as Jung mentioned, it's like a very temporal, like a versatile installation in during the weekend or peak times things. So, and also we can expand the graph, I mean, let's say network analysis to three-dimensional, you know, things. It's not just confined in the 2D. area. So actually the student already did several experimentation along the z-axis with the network analysis, but the lack of limited time, they couldn't cover that one. So actually, if I remember correctly, from the last meeting, they tried to focus on one particular exercise to convey their idea. So I think that one is the installation where they build something on the playground in an elementary school. So yeah, I think your question is a very good things to reinforce your sort of strategy to develop your design as the next steps.
Actually, at first we want to analyze three-dimensional NNA tool. So we want to make a multi-floor building, and then we want to calculate the circulation of each floor. But actually, it is also the limitation of our team. But the time wasn't enough for us. It cannot be an excuse, but at least we tried our best at, yes.
I guess the most important point in your research is that they try to separate different, let's say, types of paths, like a round trip available paths or one-way trip, and then they're trying to separate them and trying to reconcile how they regulate the paths, like one-way or two-way, based on the 6-bit rule. So I think if you guys emphasize this kind of strategy on the slide at last, I think that it would be great to allow us to understand you guys target or the first most important issues that you are not dealing with in this research, I guess.
Yeah, you guys already very actively use the NNA tool as your kind of design decision making. You already done very well about how you define the entrance and how you define the destinations. Actually, those kind of exercises were very kind of valuable for your design, for your design progress. So I understand you guys just begin to think about the kind of pavement or more landscaping kind of design approaches first, and we actually understand you guys already tried three-dimensional kind of network circulation for the for the empty plot or abandoned plot in a city, the areas. So that could be the next step, and how you accumulate or how to integrate with your actual design proposal and this NNA tools kind of analysis results. So you guys are kind of in between now, but I can see lots of potential, so yeah, I think that could be good.
And for me, I really appreciate what you've done, because you have lots of works and then you want to achieve the design quality as well at the same time. But on the other hand, I think in this stage, in terms of networking, I think if you deeply have an idea more about different types of networking solution or networking kind of conceptual proposal, rather than just proposing a single design idea, it could be different way to finalize project, I think. So in a way, it could be different direction, but I think in 1 week's workshop, 2 weeks workshops, we can think about it, I think. So yeah, because from those kind of full set of analysis, I'd love to see more about what kind of conceptual or what kind of initial model, different types of proposed model for the networking system in the city. For instance, we can get more different size of paths or different size of blocks or different size of, I don't know, maybe nodes, etc. we can maybe produce. So I think, so yeah, so in a way, I think he needed to think about it a little bit more, in my opinion.
Great. I think we can still talk a lot more about this project, but I think as we are also coming towards the end, I want to use the rest of the time to have a bit of a general kind of feedback time, maybe, yeah, instead of talking about one particular project. And I want to pose a question to everybody here, including tutors and the students, to ask you, what do you extrapolate from this workshop, and how this will affect your work or your next project or next teaching or next study. So what do you extrapolate from these 2 weeks? Can be by anybody. I encourage also students to talk.
I think I can start.
Great, thank you.
Yeah, I mean, I'm really excited to participate in this workshop, very intense 2 weeks workshop. And most importantly, I really happy to discuss computational design approach with the traditional methodology. I think probably most of the students has not like, they're obviously fascinated in the computation design, but it's not like trained, like experienced designers in terms of computation design. So, but I think throughout the 2 weeks, we have machine learning and agent-based and network and blah, blah. I think that this kind of topic is a very important topic individually in the computational design area. And also, I mean, throughout the intensive 2 weeks, students learn a lot of things, I guess. I can see the, I mean, for the unit 3, right? So in order to create sort of agent-based system, they not only just understand the behavior, but also they also need to understand very low level like coding stuff, which is pretty, hard, particularly like object-oriented program things. So I think, exposed to that kind of environment, I think the students can have, good starting point or, better way to how to understand, how to incorporate the computation methodology within their original or their own sort of design methodology. I think this is a really valuable point. I couldn't see any other, let's say, active or very, I mean, some of the workshops, they talk about like a very one limited area, but in this workshop, you have a tutor has a different background and different strengths and different perspective. So in this context, I think the social algorithm workshop is become more variable and give us a really good place where we communicate, talk about 2 different areas into one package by dealing with multiple projects with different tutors who has a background, different backgrounds. So I think that one is really great experience to me. This is my feedback. Thank you.
Thank you. We also really enjoyed having you.
Thank you.
Thank you.
Yeah, I really appreciate you two can be participate in the workshop, and then especially today I think it was a really good chance to having like the final crit together with you guys, because like I was also thought about the because we approached the script in a very different way in the unit 2 and unit 3. And then so I think your comments today was really helpful to our students as well. And so yeah, I'm really happy to do the crit together. And yeah, and then although because of the time difference, it's a bit shame that I couldn't catch any of your lectures actually. So yeah, maybe next week I'm going to sit down and then catch up your lectures as well.
Me as well.
Me too. I need to.
I think all of us probably.
Yeah. And for me, I think I really enjoyed the second sessions. Especially, I really thank for the unit 2 and 3 tutors because I understand more about those things. And
Also, it's quite nice to see together in comparison, and Unit 2 kind of starting from some physical element from the city, and Unit 3 from this kind of social element from the city, and then design different way. So those process, I kind of realize maybe social aspect or social element of the city can kind of draw or and some delineate with by making some sophisticated formulas. I don't know, maybe I thought that. So making more sophisticated formulas, we can reach some certain levels of social element we can interpret, I guess. So that could be the next step for, I don't know, maybe next workshop, whatever, and with maybe AI. So thank you for everybody to make think those things. Thanks a lot.
Thank you.
If I may add a little bit on Jay's comments, I thank you everyone, because this workshop has been was started because we all wanted to learn something new. So not only the students, so it wasn't only like one-way teaching workshop, because I know, including all the lecturers and the tutors, we wanted to learn something. We wanted to sort of experiment in something new. So, but to be perfectly honest, I learned a lot, but still, I don't think I can sort of make a lot of the sort of sharp questions or be to make very interesting discussion. But if we may take this workshop as a sort of a starting point, and as Jay said, if we can sort of move forward and hopefully have the sort of a second session, or maybe this year or next year, then probably we can, I'm pretty sure that we won't do exactly the same thing. We probably will do we will try something different again. Then probably we can move like a step further. So looking forward.
Raise the money, please.
Raise money. Good, that's the good.
And I mean, I want to take this opportunity to say a big thank you for Namju and Jang Hyun especially.
Yes,
and
thank
also
you.
and Hanjun and Sunga as well. And I hope you learned as well by teaching for the last 2 weeks. Yeah. And of course, everyone, on all the students as well, because without your work, we probably couldn't understand. Because they're like learning and then having listening the lecturers lecture is something different from going through all of your work. Thank you. Well done, everyone.
And thank you for Uje song as well. Song.
Is he here?
Yeah.
Oh yeah.
Sorry.
You missed it.
He's here.
Yeah, he has nice video on, so that's why I didn't mention it.
You don't see his face.
because we have been recorded, right? So it might be he checked it later, so he stopped. So
a special thanks to Uje for participating in this workshop. Yeah.
Thanks. I'm still here.
Oh, is he here?
This year?
Believe it or not. I was just eavesdropping you.
Good to say that anyway.
I think this is a Friday, and we must have a pint after the meeting, but it's shame for this, right?
Yeah, normally this is the beer time, but
I'm really thirsty now.
yeah. Any volunteer from students? Oh, Chonghyun, did you want to say something? Sorry.
Oh, yeah, just very shortly.
Sure.
Yeah, I really appreciate everybody, like also like all these helping hands, like arrange these events and organize everything for this opportunity. So I'm really happy to meet this all the participants for these events, like students and tutors. I really want to catch up other kind of units and lecture as well, because particularly the unit 3 today, I think our approach is more kind of regional scale and urban scale, but this agent-based kind of simulation study is really good for like micro scale actually. So I really want to study further about that, and then maybe next time I really want to talk about the share the knowledge with the Unit 3 tutors and also students as well. So I really thank to my students, like they really work very hard, and you know, like they really, we just pushed a lot actually, NJ pushed a lot every day, you know, like try to catch up their kind of push and catch up their work every step. So, but they really did a really hard work to develop our kind of hypotheses and theories and knowledges. So we really appreciate about that. So thank you for this, offering this opportunity and having us here for social algorithm.
Thank you. It's our honor to have
Very
you
much.
guys. Yeah.
Yeah.
Thank you. I'm sure all the students are super appreciating, although it was a very stressful 2 weeks, but I'm sure this will give them an incredible courage and it's experience for their like future knowledge and future learning. So I believe this provided everybody with a good experience. But yeah,
Yeah, I
maybe.
think also, yeah, maybe, okay, you first.
No, go ahead. And maybe after Singa, maybe let's invite at least one student to speak up.
I really appreciate all the efforts and time that we all put in this workshop, and because of this limited time and also the circumstance of these workshops being held like untext by online, there was a lot of limitation probably. But even though we made some, so it was really hard to like push every minute or to push the project into like really elaborate architectural level or into like really detailed design, even though I hope that everyone earned something from this tryout. And once you guys already entered into this field, then it could be a really precious treasure to drive yourself in the future into like new trials and move yourself forward into a more like into another level, I think. Anyone from students want to share your experience or any thoughts?
Can I just say something? I mean, just very short. Yeah. I just reminded, because I was looking at my like virtual background actually. So here, like the pandemic territory. Actually, I just figured out actually who was dealing with the pandemic territory was only Unit 2, I guess, isn't it?
Especially the last team.
Yeah.
Yeah.
Hey.
Good.
Yeah. Anyone from students, please?
Oh, one thing I know, NJ and Changhyun need to leave on time, right? Yeah. If you
maybe 10.
Thank you.
10 more minutes is okay.
10 more minutes.
Yeah.
We really want to
Let's-
hear from students.
Let's finish. Yeah.
Yeah.
Today I have you talking to the Zoom for 8 hours.
Oh. Yeah, Korean people are crazy.
I know.
Oh my God. Including you.
No.
I have one suggestion before Jonghyun leave. What if we have to take a picture?
Can we do that?
Screenshot.
Okay.
At least screenshot, yeah.
I did one.
Anyway, Leko did it, right?
Yeah.
I don't have everyone in one page.
On camera. Would you sound, please?
I have 10 fingers. Right.
Uje.
Who says
Yeah, I'm
Doesn't want
my kids, so I can't share my video.
Okay, I'll post this on Instagram. Okay. No volunteer from students?
This is really disappointing. Students from Unit 2, don't you want to say only like at least thank you to your tutors? It's gonna be like last time that we all joined together.
Thank you so much.
Yeah, I would like to just add the fact that when I came to this workshop, I just had a clue about what agent-based modeling is, but I didn't know much about it. I just heard about it, and like all the details and all the knowledge which I've gained from the workshop is gonna add a lot of value to my work and my ideas. Also, not about my unit. When I look at other units' work, it really expands your horizon, and you start to create links between different things. So, for example, as Namju suggested, things. So, I think that what we were trying to do was a brute force experiment with random points, and we were trying to extrapolate data. But yeah, I really appreciate everyone's efforts and comments, and yeah, I've learned a lot. Thank you, guys. Thank you, everyone.
Yeah, good luck with your thesis, Abhyuday.
Yeah.
Thank you.
Yeah.
Thank you.
And show us your work when it's done.
Definitely.
Great.
Okay.
Okay, bye.
Okay, yeah, let's wrap it up. Yeah. We had 2 brave students said something. Okay. Cool.
Thank you, guys.
Okay, it's great work.
Yeah.
My pleasure.
Thank you.
Thank you very
And
much.
maybe we can have a like real meeting when this Corona era is gone.
Yeah.
Where?
Yeah,
Oh,
maybe.
LA, New York, or
Maybe.
India,
Yeah.
where we can probably
In some
travel
city,
all
yeah.
around the world. Yeah.
Wow!
That'd be
Oh my
great,
God!
yeah.
Oh my
Yeah.
God! Do you see that?
Do you see the screens of Hajin and so?
Yeah, great.
So cute.
Screenshot.
Okay. Yeah.
All right. Thank you very much.
Okay.
Yeah.
Thank you.
Thank you.
Guys,
Alright.
yeah.
See you
See
soon,
you
right?
next year. Yeah.
But
Bye. Good luck.
Catch up. Bye-bye.
Bye.
Bye.